There we go. Okay, so for the purpose of the notes, we're going to also expand just like we did on the warm-up. Whoops. Let me, hold on. Okay, so here in the warm-up, we had like 2 to the 3rd power raised to the 4th power. Here, it's a little blurry, but this is 6 to the 4th power being raised to the 5th power. So in other words, we have 5 groups of 6 to the 4th times 6 to the 4th times 6 to the 4th times 6 to the 4th. We have 5 groups of that. 1, 2, 3, 4, 5. Then this is going to be a lot to write, but for the purpose of our notes, I think it will be helpful. Each of these 6 to the 4ths is 6 multiplied by itself 4 times. So I have 6 times 6 times 6 times 6. There's one group of it. 6 times 6 times 6 times 6. There's my second group. I need 5 total groups. There's my third group. There's my fourth group. There's my fifth group. I have 5 groups of 6 to the 4th power, or 6 times 6 times 6. Go ahead and take a minute to write that.
Couldn't you just multiply 5 and 4 and get the answer?
And that's exactly what our rule is. But I want to expand it so you can actually see that 6 is being multiplied by itself 20 times, and that's where the rule is coming from. So Jake realized from the warm-up that instead of writing all of this out, and we won't expand it each time, we're only doing it for the purpose of the notes here, but when you're finding a power of a power, what that means is you have this exponent of 4 being raised to this exponent of 5, the rule is that you multiply the exponents. Yeah. No, that's okay. You can go straight to 6 to the 20th power because 4 times 5 is 20, or if you wanted to, you could expand it out. You don't have to. It's a lot of extra writing, but we're just doing it so you can see where the rule is coming from. So looking at a few examples, right? We just said that when you raise a power to a power, this is a little small, hold on, I'll zoom in a little bit. So when you raise a power to a power, we have 8 to the 3rd raised to, 8 to the 4th raised to the 3rd power. When you have a power to a power, you multiply the exponents. So I'm going to keep my base of 8, 4 times 3. What does my exponent become, Molly? 12. Now, if you're not sure where that's coming from, then you can expand it. That means that we have 8 groups of 8 to the 4th times 8 to the 4th times 8 to the 4th. If you read it this way, then you can go back to your rule that when you're multiplying the same bases, you add the exponents. 4 plus 4 plus 4 is the same thing as 3 times 4, and that's how we get 8 to the 12th. What about the next one? You're welcome. So for this next one, I have k to the 7th raised to the 5th. So I'm going to keep my base. When I have a power to a power, what am I doing with that 7 and 5, those exponents? Multiply. 7 times 5?
35.
Good. So I get k to the 35th power. Again, if you need to, show 5 groups of k to the 7th. No, I'm only doing it for the purpose of the notes. If you need to see where those 35Ks came from, you can expand it out. You don't have to. That's the purpose of the rules. You don't have to. No, only if you're confused why there's 35 of them. Yeah.
What happens if you like to do the K7s 5 times? Can you put that as an answer too?
Here?
Yeah.
You would then want to simplify that. So this is your work to get to k to the 35th. Because remember, when you're multiplying the same base, don't you add all the exponents?
Yeah.
So 7 plus 7 is 14, plus 7 is 21, plus 7 is 28, plus 7 is 35. Yep. Good. All right, let's look at C for a second, because that one, it says try on your own, but I want to talk about it. So this one's kind of interesting, because we can see that we have 3 squared raised to the 3rd power raised to the 2nd power. So if I were to expand that, that would be 2 groups of 3 squared. Hold on. That's 2 groups of 3 squared to the 3rd power. Oh wait, there's one group. Another group, 3 squared raised to the 3rd power. That's 2 groups of that. Inside each of those groups are 3 groups of 3 squared. 1, 2, 3. 1, 2, 3. So I'm just trying to expand what's going on here. You have 2 groups of what's inside, of 3 squared raised to the 3rd. You have 2 groups of that. Inside each of those 2 groups, you have 3 squared multiplied by itself 3 times. If you notice, here you have 3 squared times 3 squared times 3 squared. You have 6 groups of 3 squared, right? In other words, 2, 4, 6, 8, 10, 12. This answer ends up being 3 to the 12th. You're still multiplying all of those exponents. 2 times 3 is 6, times 2 is 12.
Oh, yeah.
It is the same thing. I just wanted to expand that one so you can see I can continue adding these outer exponents. It doesn't matter how many I have. I'm still multiplying all of them to figure out how many bases of 3s are being multiplied together. Does that make sense?
Yes. Yeah.
Does anybody want to see that one again? Yeah? Do you want me to expand it? Okay, so let me show it live again. Hold on. Yeah, go ahead. So from this outer exponent, that means that I have 2 groups of 3 squared raised to the 3rd power. So that really looks like 3 to the 2nd raised to the 3rd. I have one, I don't even need these parentheses on the outside. I have 2 groups of that. 3 squared raised to the 3rd. Now, in this group, because this outer exponent is 3, that means I really am doing 3 squared times 3 squared times 3 squared. And then here, because this outer exponent is 3, I'm really doing 3 squared times 3 squared times 3 squared. So I have 3 squared being multiplied by itself 6 times. Right, so if I stick to my original rule that when you keep the base, when you're multiplying the same bases, you keep the base and add the exponents. I have 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12, right? Or you can see that when you're multiplying a power of a power, you take all of these exponents and multiply them together. 2 times 3 is 2 times 3 is 6, times 2 is 12. That's how I get a direct answer of 3 to the 12th power. Does that make sense? Okay. Okay, good. Any questions on that one? I know that one's weird. All right. I'm guessing you guys tried. If you haven't already, go ahead and try A and B. Give you guys a couple minutes to do that, or like a few seconds. Yes, go ahead. Did anybody not finish A and B? I know some of you work ahead. Okay. These two, we're gonna go over these two. So here, you could expand this, or you could just realize when you have a power to a power, we're gonna multiply. What does A become? How many times are we multiplying 2?
10.
Good, so we have 2 to the 10th power. And what about B? We have B to the 4th raised to the 6th. How many, sorry, I said B, I meant W. How many times is W multiplying together? Good, 24 times. We definitely don't want to expand that one out. We'll be here all day. Questions on the first section? Okay, this section is not any different. The rules are still the same, except now we've added in a coefficient. And sometimes this coefficient can cause a few problems. So let's expand it. We'll talk about the rule, and then we'll continue to talk about how to address that coefficient. So this is a little blurry or hard to read, but this says 3a, oh wait, hold on. You can't see, I gotta move down. We gotta get through this week first. Let's focus on the lesson before we focus on spring break. So this is 3a squared raised to the 5th. So this is telling me I have 5 groups of 3a squared. There's 1, 2, 3, 4, 5. 5 groups of that. Now remember, when you're multiplying, the order in which you multiply doesn't matter. So I can regroup this so that I can pull all my 3's together. 3 times 3 times 3 times 3. 1, 2, 3, 4. I have 5 of them. Right? You can see how they're all coming out. And then my a's. A squared times a squared times a squared times a squared times a squared. How many times is 3 being multiplied together? 5 times. So in other words, we have 3 to the 5th, right? There's 5 of these 3's being multiplied together. If I were to add in those exponents of 1, 1 plus 1 plus 1 plus 1 plus 1 is 5. I have a squared being multiplied by itself 5 times. So if I keep my base of a and add my exponents, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. I think most of you realize that 2 times 5 is how we're getting the exponent of a, right? But this exponent of 5 for the 3, that's where a lot of students make mistakes. They forget that exponent. So this is what I'm going to suggest you do. Right? This was our original problem. Add in, remember how I kept saying those exponents of 1 are going to be really helpful next week? Here we are, it's next week, we're here currently. These exponents of 1 are going to be really helpful. Add those in, because what we're going to do is we're going to distribute that exponent of 5 to that exponent of 1. When we distribute, we multiply. We get 3 to the 5th. 5 times 2 is a to the 10th. So do you see what I'm saying about adding in those placeholders of 1 for the exponents? That's going to be super helpful in this section, because that's where usually students make mistakes. They forget to distribute. This exponent of 5 has to hit this exponent of 1, and when we distribute that, we multiply. Still multiplying the exponents. So to find the power of a product, we still multiply the exponents. However, let's make this little note. Add in placeholders of 1 when there is no exponent. Sorry, I sound like a computer. So when there's no exponent, for example, that 3 didn't have an exponent, we're going to add in that placeholder of 1. So now we know that we need to distribute and multiply, and maybe I even want to say distribute in parentheses, which means multiply the exponents. So the exponent on the outside needs to hit every exponent on the inside. Am I making sense? Yeah. Okay. What? That's the risk you take when going to the bathroom in math. Here, when you have an exponent of, when you don't have an exponent written, you want to add in a placeholder of 1. So all these notes, because that exponent on the outside is going to distribute and hit every exponent on the inside. And when you distribute, you multiply. Yeah.
May I go use the bathroom?
Go ahead. We're good? No, it's okay. Okay. All right, so looking at this one, the first thing you want to do is add in that placeholder of 1 for the exponent of 4. Because what's happening here is this exponent of 4 on the outside needs to multiply to that exponent of 1 on the inside, and we end up getting 4 to the 4th. This exponent of 4 on the outside hits the exponent of p and multiplies, we get p to the 12th. If you don't believe me, expand 4 to the first times p to the third times 4 to the first times p to the third times 4 to the first times p to the third times 4 to the first times p to the third. I have 4 groups of 4 to the first times p to the third. You can see 4 is being multiplied by itself 4 times. That's why the exponent became 4. P to the third times p to the third times p to the third times p to the third. Keep your base of p, add your exponents. 3 plus 3 is 3 plus 3 is 9. No. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Yes?
So what I'm getting at here is the exponent is on the outside of the parentheses. When you have variable, you distribute it.
Yeah, like either way, if it's just a variable, I guess you can say you're distributing here and multiplying.
But if you have a variable, then you distribute it to the variable and the number.
Correct. So this number didn't have an exponent. That's why it's really important to put that little exponent of 1 as a placeholder. So you know that this exponent on the outside has to distribute to this exponent of 1, multiply, and the variable's exponent as well.
Alright.
You're welcome. Good summary. I like that. Okay, there's our answer for 3. Justin, go ahead.
Can I do the next one?
Yes, let's add in our little placeholder of 1 for the -2. Okay, go ahead, Justin. What are we doing here?
So -2 to the power of 5, and then you have to do the exponent of 7 times 5. So you get m to the 35th power, and then n to the 30.
Good. Now the only thing I wanted to add was that because that base is negative, you have to keep, remember your negative and fractional bases, can you see what I'm writing? Yeah. Bases need parentheses. So I'm it almost looks like I'm separating the -2, but I'm just putting it in its own set of parentheses. The m and the n, they don't need parentheses because we don't know, they're not negative, right? They're just regular m and n. But the -2, we have to put that in parentheses, and the exponent technically goes on the outside of the parentheses for the negative, because you're saying the entire -2 is being multiplied by itself 5 times.
I don't understand this basically.
This one?
Yeah.
Or like this rule?
No, like,
This specific one?
yeah.
So really what we're saying is that we have 5 groups of -2, m to the 7th, n to the 6th. Guys, if you're okay with 4, you can move on to D, E, and F. If you're not sure about 4, just continue tuning in. So that means we have 5 groups of this, right? This whole mess. -2, m to the 7th, n to the 6th. So if I expand that, that's -2, m to the 7th, whoops, n to the 6th. -2, yeah, Marcus is back. Go ahead. N to the 7th, n to the 6th. 1, 2, 3, 4, 6. No, 1, 2, 3, 4, 5. Sorry, I don't want to count. So you see how we have -2 times itself 1, 2, 3, 4, 5 times.
Yeah.
So because it's a negative base, we have to put it in parentheses. It's being multiplied by itself 5 times, so that's -2 to the 5th in parentheses.
Okay.
Then I have m to the 7th times n to the 7th times m to the 7th times n to the 7th times m to the 7th, right? When I'm multiplying the same bases, I keep my base and I add my exponents. 7 plus 7 is 14, plus 7 is 21, plus 7 is 28, plus 7 is 35. Don't you get 35 when you multiply 5 times 7?
Yeah.
And then I have n to the 6th. N to the 6 times 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 n to the 6. You're going to keep your base, add your exponents. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30. Don't you get 30 when you do 6 times 5? Does that make more sense?
Yeah.
If you're confused, Jorge, there's nothing wrong with showing this work. I like to show that work because it helps you visualize where are those -2's coming from, where are those m's coming from, where are those n's coming from.
For F, it says like there's Z, but there's not exponent. You add a 1 placeholder, there's Z.
Yes, definitely. I like how Sabrina realized that our z didn't have an exponent. Go ahead and add that placeholder of 1. You want a placeholder of 1 for the exponent of 6. You want a placeholder of 1 for the exponent of 8. Anytime you do not see an exponent, you're going to draw in those 1s. That's your first step, because otherwise you'll make mistakes. Yes?
So would it be negative 5z to the third, or?
Negative 5 in parentheses to the third, then z to the third, because you can separate them. The z doesn't need to be in the parentheses, but the negative 5 absolutely does, because it's a negative base.
If you put the z in the parentheses, did you get that wrong?
Not necessarily, but you do want to break them up. Like keep your coefficients together, your z's together, and then your w's together. Yeah.
So you put the negative in the parentheses.
Anytime you have a negative or a fractional base, it needs to be in parentheses. Yeah. So then this w raised to the 8th raised to the 3rd power, 8 times 3 is 24. Again, if you don't believe me or you're having trouble seeing that, there is no shame in writing this out. Some students are like, oh, that's so much work. Listen, it's not more work if it helps you get it right. Remember, the goal here is to be successful, not to be lazy. So if you want to be lazy and get it wrong, that's on you. But the idea is to do well and to understand. So if it helps you to write it out, there's nothing wrong with that. There's no shame in that. Then you can see you have negative 5 being multiplied by itself 3 times. You have z being multiplied by itself 3 times. You have w being multiplied by itself. 8 plus 8 is 16, plus 8 more, 24 times. How am I doing on time? Okay, I have like about 5 minutes. Yeah.
For this one, you've got parentheses or no?
You don't need the parentheses in this one because you don't have any negative bases. So you could simply just write this as a squared b to the 18th. So you only need the parentheses when you have a fractional or negative base. What did we get for E?
Oh,
Jake R?
I got 6 to the 4th power, x to the 20th power, and 1 to the 5th power.
Beautiful. Nice job.
I know we're not really on this, but at the bottom, the very, very bottom, number 4, would you just, like, use the ruler for that in the cash rule?
Yes, so this is a mixed review. I'm glad you brought this one up. I wanted to talk about this one. So notice how in my parentheses, I'm adding the little placeholder of 1 for the variable of x. So I'm going to ignore the denominator for now. This top rule is what we just talked about. This means I have x to the 3rd, y to the 12th in my numerator, right? Because that x really has an exponent of 1. And when you distribute that outer exponent inside, 1 times 3, that's how I'm getting x to the 3rd. Yep, you're good. And then y to the 4th raised to the 3rd, that's 3 groups of y to the 4th, in other words, y to the 12th. Now that I've simplified the numerator, I'm going to put my denominator back in.
So this would be x to the 2nd, y to the 11th.
Beautiful.
So you subtract, you put the ones that you subtract.
Yep, I'm going to separate my fractions. If this is helpful, show this work. Whoops, hold on. I have x to the 1st in the bottom and y to the 1st in the bottom. Justin, what's the rule when you're dividing the same bases? How did you get x to the 2nd? What'd you do with your 3 and your 1?
I subtracted 1.
Good. So here, when you're dividing the same bases, you keep your base, subtract your exponents, you're left with 1 in the denominator. Here, same thing. I'm dividing my bases, I keep my base, subtract my exponents, I'm left with 1 in the denominator. I don't need that denominator of 1, so therefore this becomes x squared y to the 11th. These denominators of 1, oh wait, you can't see what I'm doing, I'm sorry. These denominator of 1s are going to come into play tomorrow, right? We've been adding in those placeholders of 1 for your exponents. You're seeing y today. You're going to see y tomorrow. We've been keeping those placeholders of 1 in our denominators. I do want you guys to notice that on your homework, right, we have a little bit of mixed review here on our notes, but you also have a little bit of mixed review on your homework as well.
What is our homework?
I got to give it to you. Number 3, yes, I can do all of these real quick. This is going to be a to the 27th. This is going to be, Justin's singing. Negative 35 x to the 6th. This is going to be n to the 48th. This is going to be m to the 4th. Am I okay to end the recording? Okay. It will be on Google Classroom.